The third application is the computer control systems, which means a set of devices like sensor with a microprocessor and actuator that will work together to do an objective set, like, for example, painting a car or building temperature control. We will study the robots in manufacturing. They do have a great role in the manufacturing, a production line control, and finally the autonomous vehicles. With the robotics in manufacturing, we're basically talking about repetitive tasks. They will keep doing the task all over again. They don't feel bothered or tired of doing these tasks. A robot actually is a machine that is controlled by a computer, so we can use it to do jobs automatically. How do they do these ones? We have two methods here. Either teach render, which is done by the programmer, programs the robot and see how is it taking the tasks, and then check the code and fix the code so the robot can do the tasks properly. Or the robot can be guided through a task at the first time, and then it will produce the instructions for its own, like by itself. So these robots in manufacturing, they are really expensive, but they do convince industry through the speed. They do have high speed and they will work continuously with no breaks. They do save the labor costs, so you don't need to train and retrain the staff. They do have like much higher production quality. They work into severe and dangerous environments, repetitive tasks, physical demanding tasks. This is how do they convince or they feel like we can say value for the money as a manufacturer or as a factory owner. You won't feel that you're paying your money in vain. But although we have advantages, we do have also disadvantages. If something happened for the robot, it would not, it cannot act like human being. Like they don't make their own decisions. If something happened like accident or something, the machines, they cannot act from themselves and try to mitigate the situation. No, or like they can accommodate to the new situation. So although we do have the machine learning, which is the algorithm or a computer algorithm that is trying to improve the automatically, uh, let's say the more times they are run, so they will produce themselves, and it's trying to fix this area, like to change this errors, but it's still, it's under improvement. The initial setup, the cost is extremely high. Okay, and the workers, they worry that robot cause in unemployment for human beings. Of course, if the robot breaks down, okay, we always have to have contingency plans, because if they break up, they wouldn't know what to do. So we always need another plan or backup plan if there is something wrong or the robots are not working under they are being repaired. Let's have a look to this video of ABB uh, robots working in big cars factories in China. As you can see, they would do like all the tasks, starting from cutting the aluminum, put it into slides, so starts manufacturing the cars. And the designs will be ready, and then it start cutting the parts, uh, assembling them, doing welding. Okay, and these ones, they do have like a high capacity. As we said, they do uh, tasks very fast. Back in the days in the 90s, the factories would have produced maximum 300 cars per day. Now we're talking about 1,000 to 1,500 cars per day. So as you can see here, this is 350 vehicles in a year. So this means around 1,000 vehicle per day. This is like really a huge number. The second part here is the autonomous vehicles. When we say autonomous vehicles, we're talking about the cars without drivers or driverless cars. So they would use what? They would use sensors, okay? And they will use GPS, they will use Wi-Fi to react as human being, or they will respond to external conditions as a human driver. Okay, so as we said, they will use GPS, Wi-Fi, the spatial sensor, which is sensors are used to like they use laser to detect the, let's say, the environment around it. So it will measure and analyze the environment around it in real time. So they will also need 5G to, let's say, we can say, to correspond and to cooperate with other vehicles. Okay. And to understand the traffic lights, the conditions, they will keep, like, they will be kept updated so they can control the car by the actuators. And as we spoke in chapter 5, these vehicles, they will use the microprocessor in movement. It will hit the gas, hit the brakes, do the acceleration when we say hit the gas, and it will steer uh, the driving wheel. These are like the movement ones, but the corresponding is done, as we said, with the GPS, the Wi-Fi, the sensors, and the cameras also. So these vehicles, okay, they are like much safer than human beings because there is no driver to make errors, right? They are faster, they are more efficient. These vehicles also, they would use the cost, okay? And this cost, they don't stop. For some people, they think this is a new technology. Actually, 2011, Google put the first version of a driverless car, and I believe 2016 it was in Korea, and the United States was used like a taxi. Okay, now it's running in China and other countries. Also, the disabled people, they would feel like the ones they can't drive, they will feel very mobile and they will feel like independent. They don't need someone to carry them, to take them, to drive them. There is a driverless car, so why not? I'm moving on my own. Also, the auto parking system here, like it is relieving for some people. They have problems with parking. Okay, it is less congestion. It will make the lanes also more efficient. Now, with the disadvantages, the taxi drivers and the smart taxi applications, these guys like are in jeopardy. These cars, they will take over the applications of smart transportation. And in a while, in a time, people, they will find difficulties actually to, to make licenses. They won't care actually to do the licenses, and it will be extremely expensive to buy or rent a car like that one. Also, once we are talking about uh, Wi-Fi and 5G, this means you are wireless. So this is what there is a risk of hacking, or also if the sensor fails, this will do a catastrophe. If there is a manufacturing mistakes, this will lead into accidents. So these are the main disadvantages here. The third part, the last thing, is the production line control. And production line control basically is creating a product from a raw material. We would bring a raw material, put it into a production line, have some processes on it, and then we will have our production produced using machines, maybe some workers, and they would do a complex assembly. They would do too many, let's say, complicated tasks. In some scenarios, they will command the humans what to do actually in these factories. And one of the known examples is the robotic arm, which it is doing different tasks, swiping the tools, moving things with a very high speed, precision, and with no fatigue. This is an example of the one of the robotic arms. This is another one. And you can see how it is moving in precision and doing things in a good way. So the advantages of computer controlled systems, they are very quick to respond and they can change and process data very quickly. They can also run 24/7. They don't stop. They don't take breaks. They can operate in dangerous places, dangerous areas for human beings. They can carry repetitive tasks with no error, unlike humans. They don't require wage. You don't feel like you don't have to pay them all the time every month. They are very, let's say, very multitask oriented. They will do hundreds of inputs simultaneously, okay, and still make accurate decisions. Also, we have disadvantages. Well, the hardware and the software are too expensive to develop. If there is a power cut or a problem in the electricity, the system will stop. While people, for example, or human beings, they can act in such circumstances. They cannot react in like in unexpected, um, as we said, events as human beings can. So meet you on the next one.